आइए हम सुने विज्ञान की अनकही कहानियां।
Dr. Naresh Kumar's groundbreaking seismology work at the Wadia Institute of Himalayan Geology tracks tectonic shifts beneath the Himalayas, enabling earthquake predictions, safer building codes, and early warning systems that protect millions in vulnerable regions.
Namaskar, I am Dr. Naresh Kumar, scientist E at Wadia Institute of Himalayan Geology, Dehradun. I have done Master in Applied Geophysics from Guru Nanak Dev University, Amritsar, and after that I did PhD in Seismology from Indian Institute of Technology, Roorkee, and after that I have done postdoctorate research in seismology from International Center for for Theoretical Physics from Italy under the prestigious Marie Curie Fellowship of the Europe. Mainly I am working in seismology. Seismology is the scientific study of earthquake and the seismic waves propagation, evaluation, and the earthquake structure evaluation. So this study is very much important mainly for the earthquake hazard study. So I am working indirectly in the earthquake hazard studies, and as India has a earthquake are occurring in the Himalayan region, so mainly we are working for the geodynamics of the Himalaya. As the Indian plate is colliding with the Eurasian plate and Indian plate is moving towards the north, Eurasian plate is moving towards the south, so there is a collision between these two plates due to which the mountains are building, the Himalaya is built, and that is the main cause that earthquakes are occurring. That is the generation of the earthquake which is taking place due to these two collisions, and this collision is going on, and the earthquake will generate there. Basically, our research is mainly directly related with the society, as seismic hazard or earthquake hazard is related with the seismic hazard for the Himalayan region. So that is directly related with the society, as we are working in the earthquake generation, propagation, and the characterization of the earthquake sources there. So my main research in seismology that focuses into two parts. One is to understand about the earthquakes, that what is the cause of the occurrence of the earthquake, how the earthquake occurs, what is the characteristics of the earthquake, and then we can use the earthquake data for the understanding of the interior of the earth. So basically, when there is a earthquake occur, then there is a vibration of the earth that takes place, that is due to just as the slipping of the some rocks within the earth, and that makes the vibration of the earth. So that vibration of the earth we record using the earthquake instrument, which is known as the seismometer. So we record these information, we use this information to characterize the earthquake source. What is the magnitude of the earthquake, what is the distance of the earthquake, where the earthquake occurred, what will be the after effect of the earthquake, and then also we use this information to know about the interior of the earthquake. Basically, we can say how the crust or the uppermost part of the Himalaya, or where these tectonic plates are collided, what is the characteristics of that. That we are also using this information to characterize the subsurface structure, so that we can elaborate the geometry, subsurface geometry, from where we can get some information about the generation of the earthquake, about the characterization of the earthquake, and about the seismic hazard studies there. So I am also working just as the earthquake precursor studies. We have one a very big program, multi-parametric geophysical observatory, which we built in the center part of the Himalaya. Here we study different parameter, about 11 different parameter we study, so that we can get some information before the occurrence of the earthquake. If we can have a clue that the earthquake is going to occur, although the earthquake prediction is not yet possible, and we are working very hard, but there are some clues in some different geophysical parameters for which we do the studies. And I am in this research field from last 25 years. My study started at Guru Nanak Dev, Amritsar, and I started the study for the earthquake precursory research. And after that, I shifted to CSIR lab. Here is a CSIO Chandigarh CSIR lab, where I learned about the earthquake instruments, how to earthquake instruments are built. And after that, I shifted to the CMAX Bangalore, which is also a CSIR lab, in 2004. And after that, in 2005, I came to Wadia Institute, where I joined in a project which is for a multi-parametric geophysical project. I joined, and after that, I did the PhD from Indian Institute of Technology, Roorkee. And so far that I am working in seismology from last 25 years. So I started the career from the earthquake research there, and now I am working in the seismology. Mainly my research area is the seismology, seismic tomography, which can unravel the substrate structure, mainly the crust structure. And then I am also working in the seismotectonic, so that what is the linkage of the earthquake with the tectonics? Where are the tectonics? So that can be useful to delineate the tectonics and what are the sources of they are. And then also I am working basically in the earthquake hazard studies, which is mainly main purpose for this study is there. And this India is as par to the international other, and the reason is that we are sitting at a place where the high seismic active region is the Himalaya, uh, which is a young mountain, and many earthquakes are there. So we are as par with the other international here. We can say USA, Europe, Japan, China, and mainly we can compare with those countries where the earthquakes are occurring. USA you can take, or Japan is our part. From the northern side they are maintaining, from the southern side we are maintaining, so that is also in the Himalayan region is there. Japan also, there are so many earthquake occurrence are there. You can have that 2011 earthquake, Japan earthquake is there. So the study which we are doing, that is as par as the other international institutes. We are collaborating with the industries also. We are providing the consultancy work to the hydro projects, just as we have to prepare a earthquake resistant society, so that there should not be harm from the earthquake and we can have a safe infrastructure. So we are contributing to this development of a safe infrastructure. So we are collaborating with the hydro project, we are collaborating with the landslide prone zone, we are working there. And now we are also taking part for the other glacier studies and others where the earthquakes are taking place. So this is a direct relation with the societies there. I have more than 80 research paper published in the peer review journal is there. So these are there, and those are highly reputed journals, peer review journals which are there. Recently, if I can say the Geophysical Journal International, which is an international journal which I have published. The Technophysics is the journal which I have published. So I am publishing in high ranking journal is there, and research here. This is a very good initiative as you started is there, and taking our voices to the society. I think it will be a good, although we are also doing such type of work here, also interacting with, going to schools and just outreach program we are doing. But this is also a very good initiative which can be help and give the message to the society. Whatever the Wadia Institute is doing, whatever our geophysics group is doing, whatever we are doing in earthquake or seismology is there. So if it can reach to the public, then it will be very good.
This podcast series on STEM popularization is supported and catalyzed by National Council of Science and Technology, Communication, Government of India. Produced by Media for Community Foundation. Technical support is given by Soumya Mishra.